Now we look at a more complicated example. Look at a more complicated example from here, and we can see that from here we are given y equal to the square root of 1 minus s square to differentiate or find the derivative of that particular function. And like I have said, f of x is equal to, or rather y is a function of x, so f of x is equal to whatever y is here. And from my formula here, which I have derived for the differentiation from first principle, I can use it to solve this particular quantity. Now from here I can say that all I did was also to replace this quantity here, but in this case this quantity here has 1, and you can see I have not touched the 1, because when you are differentiating a constant like 1, 2, 3, 4, or 5 or 6, the answer tends to become 0. And because of that, we will see how this 1 here disappears as we solve. And now all I focus on is my x value, which is my x square here. We can see it has a square here, so I've replaced the square here from what I have got here, and the square root is still there. So you see what I did was just replace things, and I get my nice looking function here on the right hand side. So my f of x is still the square root of 1 minus x squared, all divided by the change in x. Now from here I expand this, which I did in the second example, and when you expand this you get this nice looking function here, which is x squared plus 2x change in x plus change in x squared. And now you see I have left it in bracket because when you are working with negative signs you have to be careful on how you simplify. And since I know this negative sign affects everything here, that is why I've put it in a bracket. So when I open the bracket, I have this nice looking function here, 1 minus s squared minus 2x changing x minus changing x squared. You see, the minus opens up the bracket and changes the whole function to a negative. And now I have my f of x here, or divide by change in x. So from this step here, I multiply by the conjugate of my numerator. And you already know the conjugate is simply the inverse sign, which is plus in this case. And so I have multiplied my conjugate just like I did in the initial step, and I have gotten this as my answer. So when you multiply out this conjugate, you get this. Now recall that in the initial step, all I had was only x here, but this is a binomial. And since I know what a negative sign stands for, a negative signs always affect everything in the bracket. So if we have three quantities in this bracket, the negative sign have to affect the three quantities, just as I have explained here. Here we have three quantities, and we have, if we have four quantities, it's the same thing. But in the previous case, we have only one quantity, x, and so it was easy for the negative sign to just affect it. But in this case, we have two quantities, so the negative sign have to affect the one and affect the negative x squared also. Now we know how we got this from the initial example we did, and we can see from the next step here, my negative here has affected the 1 and also affected the negative x squared to become positive. And now from this step here, this particular step here, we can see that the numerator, or the denominator rather, is not changing yet. So I just multiply this by this and I'm getting this. So it is equivalent to this. So what I'm working on is my numerator. Now we can see that this is a positive 1. This positive 1 cancels this negative 1. And this is a negative x squared. So this negative x squared cancels out this positive x squared here, leaving me with a more simplified version of the numerator here, which is negative x squared no, sorry, negative 2x dx minus change in change in x square rather. I am using the x and changing x interchangeably, so sorry for that. They all stands for the same thing. So the denominator here does not change. And we can see that I have factored out change in x in both functions here, which I did in the previous example, and we have seen it here. So this change in x cancels out this one, leaving me with this simplified version of this function here. And now from this step here, I can simply take the limit as the x approaches 0 of change in y over change in x. And because of that, I simply replace all my dx, or rather change in x, with 0. You can see from here I have my dx here to be 0, and here I have my change in x here also to be 0, and change in x square here to be 0x square. So these are all zeros. 0 multiplied by 2x leave me with 0, or negative 2x rather, multiplied by 0 leaves me with 0 all through here. So I am left with a quantity 1 minus x square plus 1 minus x square, also both in a square root, and my negative 2x minus 0 is still my negative 2x. So we can see that this function here has been simplified. And from this step here, this plus this is simply 2 roots 1 minus x square, because both of them are of the same quantity. And I can say that my 2 cancels out this 2 here, leaving me with my answer as dy dx being equal to negative x divided by the square root of 1 minus x square. Now, in my previous video, for some reason, I skipped this particular function. I did not solve it for some reason, and this is the reason why I did not solve it. Now here we can see that I'm asked to find the derivative of y equal to the square root of 1 minus x squared. In this case, I'm not going to use the method of the first principle. Rather, I'm going to use the power rule. But the reason why I did not solve this particular function in my last video is because this particular function, unlike the others I have solved, is a different function. This is what we call the function of a function. How do I mean? Now, if for some reason x value is known to be, let's say, 2, if for some reason x value is known to be 2, I can say this here equals 2 raised to the power 2, which is 4, and 1 minus 4 is equal to negative 3. Now, negative 3 is a quantity, or is a constant, quite all right. But that is not the only answer we have here. We also have the square root of negative 3. So we can see that we have two answers here, which is negative 3 and the square root of negative 3, all in one function of y. And that is why I call this the function of a function. Now, solving a question that comes in this form, what we have to do is to set the inner function here to a particular value, which we don't know. So I set it to p. In some textbook, you will see it is set to t and some other alphabet. But you must set it to a particular alphabet that is not y and that is not x. So I chose p in this case. Now, if I set it to p, I know that my p is 1 minus x squared. So if my p is 1 minus x squared, it simply means my y is equal to the square root of p. And the square root of p in algebra can be rewritten as p raised to power half, which is what I have done in this case here. Now, I differentiate these two independently. Now, if you see, if I differentiate p with respect to x, differentiating p with respect to x, I'll have dp dx. Now we can see, sorry about that, if I differentiate p with respect to x, I don't know why this is shaking. So if I differentiate p with respect to x, I will have dp dx being equal to 0 minus 2x. Now recall I said when you differentiate a constant, in this case it is 1, it gives you 0. And when you differentiate negative x squared, we get negative 2x. Now if you have watched my video on differentiation of common function from the direct method or the power rule method, they are the same. You will understand what I have just done here. And now this leaves me with negative 2x. Now if I differentiate y with respect to p, here I differentiated p with respect to x, dp dx, and here I'm going to differentiate y with respect to p, which is dy dp, and it is equal to half p raised to power negative half. Now how do I get this negative half? It's just simply saying half minus 1, which is what I did here. 2 minus 1 is 1. And anything raised to power 1 is that same thing. That is why the 1 here is not appearing. So this is half minus 1, giving me a negative half. Now I brought down this, which is what we have seen here. Now when I simplify this, recall in my last video I said this is the same thing as saying 1 over 2 multiplied by 1 divided by, which is this minus here, p raised to power half, which is the same thing as 1 over 2 multiplied by 1 divided by the square root of p. So this is the same thing as square root of p. We can see it here. And this is equal to 1 multiplied by 1, 1, 2 multiplied by square root of p, 2 square root of p. Now what we have just done here is to find two independent derivatives, which is the p dx and the y dp. But our initial function here asks us to look for the y dx, which is differentiate y with respect to x. But we can see that if I multiply this function, the p dx multiplied by dy dp, I get my dy dx. Now dp dy is equal to this, while the x dp is equal to this. When these two cancels out, I'm left with my goal here, which is dy dx. So dy dx is simply multiplying these two functions together, and which is what I have done here. So we can see that negative 2x multiplied by 1 gives me negative 2x, all divided by 2 square root p. And in this case also, these two cancels out, leaving me with negative x squared divided by the square root of p. And this is equal to negative x divided by, what is our p here? We can recall that our p